Ranger. It does.
Yeah, it really does.
It really screams Ranger.
Yeah, like if you were to write really neat, I wouldn't think like that's not Ranger Station.
Yeah. Okay, so anyway, now that we are recording, back to yesterday, we talked about scatter plots, and y'all thought up a few scatter plot possibilities that would maybe have a correlation and not have a correlation, but some of them have a tighter correlation than others. Some of them, the points are clustered very closely to a line, and other ones it kind of forms a line. It's like in general going uphill, but the points may be separated further away from it. And so there's a way to measure how close numbers are to that line, which brings us to the top of the page where we are looking. All right, there is a calculation that can be done, and your calculator will do the calculation for you, and it is called a correlation coefficient. It is officially called the Pearson correlation coefficient. I don't have any idea who this Pearson guy is. Okay? I know a whole lot of the math history. You know, if you say Cartesian, I know it's René Descartes. If you talk about Venn diagrams, I know they're named after John Venn. I also know if John Venn had not made up Venn diagrams, I would have made them up and y'all would be calling them Stewart diagrams because my brain works like Venn diagrams. Anyway, I can tell you most of the math history. I don't know who the Pearson is. When I see Pearson, I think of the publishing, the textbook publishing Pearson. But I don't know that there's any correlation between those Pearsons.
It could also be Pearson.
Pearson, the son of a pear.
I read person.
Person. Okay. So whatever way you interpret it, it's a correlation coefficient. We can find a number that lets us know how closely all the points on our scatter plot are to this line that it seems to be forming if we think it's linear. And if the correlation coefficient is a certain amount, we can go, oh, that's very linear, or we can go, not particularly linear. Okay? So, this is, oh, I have lots of blanks here for you guys to guess. Y'all are graded, and lots of blanks for third period to just stare at and wish I would leave them alone. Anyway, a blank between blank and blank, rounded to the nearest thousandth, that measures the blank of a linear correlation. It is represented by the variable blank.
R.
It is. It is represented by R. How did you know that?
I looked a little bit lower.
Oh, have y'all started learning to use your tools? Okay, so it's our R value. Good. Okay, we got that.
A number between -1 and 1.
Okay, let's stop right there. It is between -1 and 1, but they didn't use the word number.
Variable.
Oh, getting in the right, sort of.
Coefficient?
You got the right first letter there.
Value?
It's a value. So frequently, instead of using the word number, we use the word value.
Use the most like out of the box words.
Yeah, anyway. And it measures the blank of the linear correlation.
Regression.
The what?
Regression.
Progression?
The slope.
The what?
The slope.
The slope?
Progression.
Wait.
It actually measures
Difference.
how good the correlation, but the word is not good, so it's the strength. You can do a linear regression with any set of XY points that you put into L1 and L2 into lists. So your scatter plot could look like somebody took a handful of Skittles, threw them in the air, let them fall, and then they graphed them. Well, it's not likely if I take a handful of Skittles, throw it in the air, let them fall, that they're all going to line up. Unless you like got a sloping floor and they all roll next to the wall or something. Otherwise, they're going to be all over the place. They're going to look like freckles on somebody's face. You know, if you have freckles all over your face and you decide to put your face on a grid, chances are you're not going to have a very strong correlation coefficient because your freckles are not lining up. And if they are, that's very interesting. Across your face. Okay? So you can do a correlation coefficient from any set of points. from
You'd
any
probably be a
scatter
model
plot.
if you're freckles.
But, huh?
You'd probably be a model if you're freckles.
Blah, 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 blah.
Like,
Yes,
like a
yeah,
straight line
yeah,
across
they
your
can be
face.
Anyway,
Oh,
pretty,
straight
pretty
on
cool
the
looking. Oh, it could be vertical, then you wouldn't be
Yeah.
functioning. Blah, 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 blah.
Okay, what you said about those Skittles, imagine like you have
Yeah.
the scatter plot on, you have those Skittles and like you have all the colors of Skittles and like you're like, oh, let's
graph
see
them.
which color gets the most of this color. Like, so you get an
Ah,
actual
now you can
logo.
do all sorts of fun stuff by throwing hands of Skittles in the air, other than eating them, because then they get kind of dirty on the floor. Yeah, but that's okay. I know people who still eat them all anyway. Yeah.
5-second rule.
5 second rule. Hurry, hurry! 5 seconds. 1, 2. Yeah. Okay.
Yeah, more like 5 hour
So,
work for some people.
I used to do a scatter plot experiment with my, was it my 5th graders? I think it was my freshmen. Anyway, I have to think about that and see if that's something I just want to spend a day playing with because it's kind of fun. Anyway, we can see that. We can play with that. All right. So anyhow, all right. So our R value will help us know if, without ever actually putting all the points on a graph, did they line up well or not? So here are some things we need to know. The stronger the correlation, a stronger correlation, the R value is going to be closer, okay? The closer the correlation coefficient is to either blank for a blank
Positive.
correlation. For a positive correlation. So what number do you think we're going to be close to for a positive correlation?
Either one.
1 or
Negative one.
-1 for a...
Negative.
Now what's the difference between a positive correlation and a negative correlation?
One's going down, one's going up.
One's going down, one's going up, okay? The closer the R value is to 0. Now remember, these R values are going to end up between -1 and +1. You're not going to get an R value of 72 or -1.5, okay? So give me something that could be an R value.
Negative 78.
That can't. It has to be between -1 and 1.
0.87.
I guess you're right. Negative 5.
0.87.
Wait,
.87
I don't
negative
think I should do this no more. Wait, I thought I had a point. Oh yeah, 0.8. Okay.
.87 would be
I guess
1.
I thought.
So what are you trying to say? Redeem yourself.
I'm trying so hard, but I'm not finding.
Put a point in front of your number.
0.5.
0.5 would
0.272.
0.272. 0.000000075. 1 itself,
0.314.
0.314. Give me a negative one value.
Uh,
0 could be 1.
yeah.
Negative.
Well, 0 is
0.5.
not.
Negative 0.5. Okay, so all of these are potential R values. -1 could be 1, all right? Now, if you get -1 as your correlation coefficient, it means your points perfectly lined up in a line with a negative slope. Perfectly. Perfectly.
Yeah.
Okay, they were perfectly linear. So what does a 1 as a correlation coefficient mean?
That's positive.
It's a perfect positive. What if your correlation coefficient is 0.973458267? Because sometimes they just vomit decimals all over the place.
A medium positive.
0.97.
Oh, it's a perfect.
0.97.
That's almost a 1.
Perfect.
So it's very, very close to perfectly lining up. Okay? So, anyway, the closer R is to 0, the less correlation between the,
Point.
actually it's the variables. Because yesterday I was having you make up variables that you thought would correlate and variables that would not. So the variables are what your X and Y axis are talking about. All right? So what was one of our examples yesterday that we said probably there's not a correlation between them? We all thought of some different examples. Can you remember one from our class yesterday?
Like
Yes.
photos on the phone and annual income.
The number of photos on the phone and your annual income. I cannot even fathom a connection there.
I mean, I could. So like the higher your income is, the more likely you are to spend on a higher gigabyte phone. So
Oh.
you're able to get more photos.
Maybe, okay. There's always an argument in everything, isn't
I was
there?
just
Or like
thinking
the
a while ago.
social media, like an
Huh?
influencer, like they have to take photos and like their
And
income.
able to get
comes
income.
Oh, they take more photos, okay. So I love how y'all think. Let's find the argument here. I love that. All right, you should all go to law school.
Always be an argument.
Huh?
So there definitely could always,
Yes.
almost always be.
Yeah.
Anything
And-
can happen.
Yeah.
Exactly.
So, like I said, you should all go to law school if you've got those arguing skills going. All right. So, what's something that might have a decently linear negative? What's-
COVID
that's-
cases as the years go. Like,
Okay, number of COVID cases as the years from 220 went down. In 220, they were up high, and they're tapering off. It may actually find out that although it's negative, it may not be so linear. It may be more exponential decay, and it might fit an exponential curve better than a linear, which kind of leads me to what you're going to do in your critical thinking project. You're going to gather some data and you're going to do regressions and find R values both for linear and exponential and see if the data you're gathered leans more towards one or the other and if it's a decent correlation at all. I did an experiment, but it's a terrible correlation in both cases for mine. Okay, you had a hand up, yes.
I mean, you could do like the depletion of a population, like a deletion of a population of deer after.
Yeah, and it may be going in a linear fashion.
after hunt, or like deer hunting season.
Yeah, like
Beginning of deer season, end of deer season. It could be linear. Definitely going to be a depletion, right? So it's going to be a negative correlation.
It
And
goes-
then maybe it's linear, maybe it curves down.
It could also be the number of wild animals after a forest has been cleared out.
That's what I was trying.
Oh, after deforestation?
Yeah.
You threw
That's
some
what I.
fancy words.
That's what I.
Gotcha. Okay. Or de-deerization, which is called deer season. All right.
Or like a number of Walmarts as you get closer to the poles.
So your latitude as you get closer to the North Pole or the South Pole and the number of Walmarts you find worldwide at that latitude. You do some thinking, don't
Somebody
you?
used to make a Walmart
Yeah.
in Santa's Village, actually.
Okay. I personally, now not talking Walmarts, but talking not Waffle House. Was it Waffle House? I'm gonna make sure. No, Denny's. Denny's.
Okay.
I have personally eaten in the northernmost Denny's in on the earth.
Really?
Alaska.
Yeah, it was in Alaska in Fairbanks when kid number 3 was up stationed in Alaska for 4 years, and I had to fly out every summer to go see the Grand Stewartlets that lived in Alaska. Those are now the ones that are in Georgia. But anyway, so we went and ate at the northernmost Denny's in the world. Oh!
Did they have it like as like a sign?
Yeah, it had a big old sign. We took pictures in front of it, because who wouldn't take pictures in front
Was
of
it
that
good?
sign?
Is it good?
Just like a Denny's here.
I wonder what the northernmost like fast food chain is.
I don't know, but you're not going to get too much higher than
Yeah.
Fairbanks, Alaska. When you start getting to whatever that.
Arctic
I
Circle.
can tell you what the latitude is of Fairbanks, Alaska.
Oh gosh.
I'll look right here. Okay, well, let's see if I
I-
find old Fairbanks.
I did not.
Fairbanks, you guys, is right here. Okay, so if I go around, it is about, I just lost it. It's a little less than 66 and a half, that's 60, so it's about 65 degrees north latitude. And, so if I were drawing a circle around here, I don't know how many fast food chains are much higher than Fairbanks.
Yeah.
Okay,
That's so cool.
I mean, there's,
I mean, there's not really a lot of people to serve up there, you know?
yeah, not really. Not-
Yeah, but I feel like just for the marketing, you would have to.
Yeah, you're not gonna be serving a lot of people in the middle of the winter.
More of like a tourist attraction. so-
Yeah, that's what I mean.
Yeah, okay. All right, so as we look, I found this nice little graphic, okay, R value of 0, Skittles, or freckles, or whatever. There's just no correlation on this center one, is there? All right, here we have a clear negative trend, correct? But here we have a much tighter negative trend. So this one's almost lined up perfectly. It's very close to -1. This is a positive, almost lined up perfectly. We're closer to a +1. 0.8, -0.8, pretty decent linear correlation. So let's kind of use this information and figure some stuff out. Okay? How to find the correlation coefficient? Well, first of all, that means you need to put X, Y values into your calculator. Where do we put lists of numbers in the calculator?
Stats.
In stat. So if I go to stat, how do I put lists in?
Edit and then go to L1 and then go up.
Okay, so we learned the other day how to clear out L1. So I'm sitting on the letters L1. How do I clear that list?
Go up and press
I hit clear. What do I not want to hit?
delete.
Don't delete it or you'll just have to clear your whole calculator and it'll come back. Now I press clear and nothing happened.
Hit enter.
Oh, now the magic has happened. All right. So we're putting in 2 variables here.
Okay.
And we learned the other day the value of double and triple and quadruple checking to make sure you got the correct data into your calculator.
Yes, but are we doing L1 and L2 this time?
We will do L1 and L2, so that will represent X for L1, Y for L2. And if you have a table that's going sideways, the top row will be your L1, the bottom row will be your L2. Okay? So, if you don't get them in correctly, you will not get the same answers I'm getting, unless you put them in correctly and I didn't, and that happens sometimes.
So we're putting the BMI.
Yeah, BMI is going in first. What's BMI?
Your body.
Body mass something?
Yes.
Okay, does it say in
Body
the,
mass
it doesn't, index, body mass index? Which is, what's it telling you? What does that mean? What do you know about that?
Your fat, I guess.
It's kind of like how fat or lean you are in general, right?
Yeah.
Yeah. I'm working on upping my BMI. I've been consistently raising it for the last 4 years. And now that I'm talking, I'm not confident at all about that list of numbers.
I'm pretty confident in mine.
Okay, well, I'm just going to be confident, and if I come up with the right same answers that I came up with on my answer key, I'm going to go good. And if not, I'm going to go back and find my mistakes.
Alright, linear regression though.
Hang on, I haven't even finished typing this one in, but your directions are there for you. See if you can
It says
figure it out from my type directions while I keep putting the values in.
So it's linear regression, so 4, enter.
Okay, so we got a nice little set of directions for doing a linear regression. Okay, all right, so we're going to enter it stuff. We're going to go y equal.
Yep.
Okay, so check this out. I have a function already in y equals. What do I need to do about that?
Clear.
I need to clear it, and I totally changed my window last period, so I am going to have to get my window back to normal. -10, +10, -10, +10. I probably should have just cleared my calculator. Anyway, all right, so going back to that. All right, enter my data into L1 and L2. I'm going to go to y equals. Have you ever looked up above y1 and seen where it says plot 1, plot 2, plot 3? Have you ever noticed that? Have you ever used that before?
Never used it.
Okay, it turns on, it will show your data plotted. So I have to go up.
Students, just a reminder, 8th grade students that did your course selections yesterday, do not forget to turn those in to me today or Ms. Monso. Thank you.
Okay, go up where you have plot 1 and you're flashing on it and hit enter. And what that does is that tells the calculator, I want, when I look at the graph, I want you to show me the points that I just plotted. Now, if I go look at graph, I don't see any points
Because we're too close to the center.
because we don't have a window that shows the numbers we put in. We'll fix that in a minute, but I'm going to go back to where I was. I've turned on my plot 1 at the top, all right? I need to adjust the window to show my data. So, what were my X values?
BMI.
Okay, my BMIs. What's my lowest BMI?
22.4.
Okay, so I've got 20, nope, we got lower, got 21.6. What's our highest one?
27.9.
Okay, if I don't want to put in decimal numbers, what's a good lowest decimal number? Or not with a decimal. What's a nice whole number?
20.
Okay, we could go from 20. I did 21, but honestly, you go 20. Okay, if I went from 21 through
30.
26, or would 20 to 30 even matter? Okay, 20 to 30 would be fine. You're just trying to make sure you've covered your lowest to your highest, right? For your X values. And what should I put in for my Y values? Now, in this case, I didn't say to give me a lowest. They gave me a lowest of 0. And what's my highest age that I see?
6.
Okay. Now, it says, why don't we choose a Y scale that counts by 10? So if I was counting by 10s, how high would I need to go to cover everybody on here?
60.
Okay, but if I stop at 60, then 1 point's going to be at the edge of the screen. Why don't we go to 70? Okay, now, so let me show you how to change that window. Have we done this before?
Yes, ma'am.
Okay, so I'm going to window, and for my X values, I'm just going to go from 21 through 26. Now, honestly, you could say 0 to 30, but you just have a whole big old gap because there'd be nothing between 0 and 21, would there? All right, for my Y values, and I'm just going to count by ones. Okay, so this X scale says, what are they counting by? All the ones. So what do I want to put for my Y minimum?
0.
Max?
70.
And what do I want to count by here?
Just grab it.
Count by tens. If you don't tell it to count by tens, it's going to try to draw 70 lines in a screen that's this big, and it's just going to look like a solid, thick Y-axis. Okay?
Okay, I pressed graph.
So now, if we push graph, look what you see.
I don't see dots on mine. What'd you do? Did you put the plot 1?
Did you, okay, go back to your Y equals. Does plot 1, is the plot 1 black if you hit Y equals? Look at this.
Yeah.
You have plot 1. Okay. All right, go to your window.
Everything's right on that.
Did you clear your calculator at some point and get rid of it?
There's nothing still there.
Okay, so go to your, I'm sorry. Okay, there's an answer to this, and I don't know. Okay, got our plot. We got our window. Your Y max is not 70, it's just 7.
Oh.
We got the-
I was thinking, what's going on here? Try it with a 70.
Okay. There we go.
Okay, because check it out, because around 7, I got nothing there. Now we there? I knew there was something. It's like, oh, how is this not working? Okay, so take a look at that scatter plot. Do you think it's very linear?
Kind of.
Yeah. I
There's
think
Okay.
some outliers.
What sort of R value do you think that might give me?
R.4.
Something
Maybe
around
0.4.
0.5.
She's saying 0.4.
0.1.
But you're all saying positive numbers though, right?
Yeah.
It's not total Skittles,
And it's going up.
but it's not great. So I got 0.4, 0.1.
like, somewhere between like
Somewhere between 0 and 0.5.
Okay,
somewhere around.
so we can get the calculator to do a couple of things for us. So over here, we can find the correlation coefficient, and we can get the calculator to give us the equation and actually put the equation into Y1 where we don't have to type it ourselves. But don't go too fast here or you're going to miss it. Okay, are you with me?
Yep.
Okay, I'm going to go to the mode first, because if I don't set up my mode to diagnose my scatter plot, it won't give me my R value when I do the aggression. I'm going to aggressively regress this line. If you come down here, way down on this list, do you see where it says stat diagnostics? Okay?
Stat wizard.
Okay. I don't know. I read something about it the other day, but it was one of those things you read it and it's like, I don't know what they're talking about. So I didn't learn anything, but I did read about it somewhere in the textbook about the stat wizards and what it does, but it didn't really affect me, and I moved on because I was trying to get these Unit 8 notes typed up real quick. Anyway, you have to turn the diagnostics on. If you do not have diagnostics on, you don't get an R value. So I am going to go over till on is flashing, but I haven't chosen it until I hit what? Now I've chosen diagnostics. Step 1, good. Now I'm going to go to stat. All right. Edit enters the list. We've already done that set step. We've got our list in L1 and L2, correct? So we're going to go over to calc number 4, and don't go too quickly here, okay? Because if you go through this too quickly, you'll get your R value, but it will not put your equation into Y1 for you. So kind of carefully, we're saying, hey, yeah, L1 is my X list, L2 is my Y list. I don't even know what this frequency list means, but stop right here where it says store your regression equation, and we want to store it into Y1. So Y1, how do we find this? Okay, did I type how to get to Y1? I don't think I typed it. Okay, I have to play with this a second. Okay, I think it is alpha trace, but watch me. Okay. When you hit alpha, these become what are called hotkeys, and they have extra menus. I think if I hit alpha trace, it gives me an option of where to store my equation, and it already thinks I want to put it in Y1 because it's got that one blacked out, right? So I hit enter, and now my equation, I will not have to copy it onto paper and then type it into Y1. It's going to appear in Y1. I probably will have to copy it onto paper just to answer the question, what's the equation of your regression line? And then I go down one more to calculate, and instantly, and which just blows my mind because I know the hard work that would go into this if the calculator didn't do it. But instantly, it writes it. Now, what's interesting about the format of this equation?
Y equals AX plus B, but it's not M.
Yeah, so they're using A for the slope instead of M. And they give you your slope. It's about 4.47 blah, 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 blah. And they give you your B beginning value. If they drew a line, it would be B beginning at negative 60, okay? They give you an R square value and an R value. We are looking for the R value, which happens to be the square root of the R square value, all right? We're looking for an R value. So all of that is there, all right? So now it has put that into Y equals. Go to your Y equals. It put that into Y1.
That's so cool.
Okay, now I really should have told y'all to clear the calculators beforehand because some of these calculators had trig equations from last period sitting in them. So if this has a cosine or something else in it, I don't know if it would have replaced it or just added it to the end of it or whatever.
So what did
But
you
anyway,
can you do what you did again to put it into?
I don't know, just okay, do you want to see what I did? Okay, so I went to stat,
Yeah, stat and
calc,
you go to the store.
number 4, scroll, stop, and it's alpha trace. And then you can put it into Y1. So in your notes, folks, you might want to write alpha trace
I'm clear, my calculator.
Y1. Oh, but that means your
It's
whole...
okay, I'll redo it again.
Okay, your whole list just went away. Your L1 and L2 just went away.
That's fine.
That's okay. Okay? So for now, just taking the notes on this example, just use what I have up here because we're going to do other ones. Okay? So if I go to y1, my equation has been typed there, but good gravy, it has vomited decimals all over the place, hasn't it? So, did I tell you where I want you to round? Okay. So, I want you to, huh?
In the box on the right, it says equation with values.
I did tell you where to round. Thank you for seeing that, because I was having trouble seeing it because my calculator was sitting on top of it. So, write the function. I was trying to say equation and function at the time. Write the e function and round your values to the nearest thousandths. How many places is thousandths? 3 places. So, we have to write the equation, and we have a new symbol, kids.
A Y with a house on it.
A Y with a little carrot, housetop on it, okay? So, if I go back to the beginning here, I am going to write Y equals 4 point, give me 3 decimal places.
Oh my gosh, I forgot how to do it.
You forgot how to do 3 decimal places?
4.732.
Not that.
7,
No.
3,
No, 473.
oh, okay,
Sorry, I missed the number.
I got you.
I especially would have overwritten it,
You would have overwritten what?
the function that was already there.
Did it override it? You think, or did you just try it and see?
I just put in a different function, then tried it again, and it got replaced.
It just overrode it. So if there was something in Y1, it just made it go away.
Yeah.
That's nice. Okay, possibly because it takes up so many dadgum digits. But if this was shorter than what was there, the extras of it may have been, because if you start typing in it, it's going to cover up as many places as you type if you were. So who knows? Anyway, okay. I'm okay with not knowing that in my life. I'm just going to try to remember to clear any old ones. Okay, what goes after this first 4.473x? Now, it says plus a negative.
Wait, but were you not supposed to delete it in the calculator?
Well, you have to write it down. So it's okay, just run your regression, it'll put it back again. Or just follow mine and we'll do a new one in a second, okay? So, am I going to put plus a negative? I'm just going to put minus. My calculator's wanting to go on to sleep. It looks like 60 point. So I'm going to have to scroll over there.
60.085.
085. Because it also gives you those numbers on your regression before it puts it here. So are we rounded correctly? Okay. Now, I probably, if I go back to the home second quit, my regression values are gone. But look, they're gone, but the instructions are there. So I can just go up and say, do it again for me, hit enter, and it gives me the same stuff. So I could have written my equation by looking at this and gotten my R value by looking at this. And so for the correlation coefficient, all right. Now this one, I didn't round it at all.
So just
Okay.
write all of that.
For accuracy, we're going to give me the whole thing. 0.576. Who said they thought it'd be around a 0.5? Somebody said
I
0.4.
I said around 0.5.
0.5. So it's almost at 0.6. Even though it's kind of scattered all over the place. But it was still kind of going up positively. 5763078. Whoa, okay. 191. This is not the same thing I have. Oh, I bet you I just copied a 3 instead of an 8 last time because everything else matches. So I think I jotted it down incorrectly in my notes. So there's my correlation coefficient. So okay, now, why did I bother to put it into y equals if I could copy the equation here?
So that you can see the line.
Because now I can go to my graph, which still has the stat plots turned on, and I can see my scatter plot and my line of best fit together. There are some points that are very close to it. There are kind of equal a number above and below. That's what strengthens up my correlation coefficient. All right? But according to this, okay?
I think it's medium positive correlation.
Okay, do you even think it's medium or not?
I don't know.
Okay?
It's very.
All right. How well does it fit?
I
Can we
say
get
low
small?
positive correlation.
Okay? So it's not great.
Not great. Perfect.
Okay? All right. According to the R value, it's not great. Oh, sorry, I didn't write that where you could see it. Okay. According to the R value. And looking at the graph, it's not great looking at the graph. And in your notes, why don't you kind of sketch a bit of a picture of what you see? You got this positive line and some points above and some points below. I don't know. All right. It's not a super tight fit. So we're going to find out as we go further into the notes, how do you evaluate? What numbers are great? Okay. Up here on this page, we have, if you get in the 0.8s, that's medium strength. So 0.5, not great. So we will find that out.
Wait,
As-
there's two blanks. It says line of best fit.
Okay.
Right.
View the graph to compare this to the, I didn't write that. Good for you. I didn't even write that in my notes. To the line of best fit. So,
I saw those, I just forgot those were blanks.
Yeah.
huh?
I saw those, I just thought they weren't there.
Yeah, I never thought to fill them in when I filled in my notes. Thank you for being on top of things. This is why y'all are my guinea pig class. I love y'all so much. All right, so we turn the page.
Line and best.
Oh,
Wait, what does that say?
okay. So the significance. What does
Wait,
the word
what?
significance mean?
These two. Down here at the bottom.
Line of best fit.
Line of best.
Line of best fit. Okay.
Coefficient correlation.
Okay, put those words backwards.
Or
Correlation coefficient. Okay, but I asked, let me finish writing that now that I've started it, and then I'll ask my question again. Correlation coefficient.
I hate writing that.
Okay, I am totally okay if forevermore you abbreviate it with COEF because I can't think of any other words that start with COEF and coffee doesn't. Okay? Now, what does the word significance
Like
mean?
prominent.
Prominence?
Important.
Notable.
Importance, notable, okay, something of significance. Or I think with your importance is, what is the
How useful.
importance of this? Why?
How
What's
useful
our
it is.
significance here? All right? So the correlation coefficient, also known as the R value, can help determine if the blank between the variables is statistically significant. What?
Relationship.
You are dead on it. Relationship. So yesterday we were making up variables, and then and even today, and we're arguing if we thought they correlated. The R value tells you how well they coordinate. So if the correlation coefficient is less than 0.5, okay? Or-
Less that, yeah.
Oh, gee, that needs to be fixed. Less than 0.5. Let's see if I can pull up this unit and fix that. Okay? Or that's the positive version. So, or it would point five. No. Oh, so the absolute value of your correlation coefficient, I like that too. Okay? All right. So our correlation coefficient on the last problem was just barely higher than 0.5. So it wasn't great.
The corner.
But according to this definition, ours is statistically significant. So we're going to stop there and get a little more detailed with that, because it also depends on how many data points you took. If you just got 2 data points, y'all, you can always connect 2 points and draw a line. So you get greater significance depending on the number of data points you have. All right. Bye.
You saw the video?
No, I didn't even start the video. Okay, I have to video this period. Thank you. Okay. Jacob just asked if you stop the video. I didn't start it, so y'all have got to tell me to start the video. Oh my stars. I was so excited about teaching about correlation coefficients. I forgot to start my video. Howdy. Remind me to start the video after that. Y'all should be turning in your CMHW 8.3, unless you turned it in yesterday. Hayden, also box of whiskers. We're supposed to be turning yesterday.
Hey, Cliff. Hey, Shannon.
So who's that? I don't think it's him. Who is that?
Hayden.
Heyman who? Is he Hayden's cousin?
Yeah.
So who is this guy?
Robbie Collins.
Would they have called him Robert? Oh, okay. And Hayden's dad is Warren, right? Because I remember teaching a Robert. You're like 4 brothers and everything. All right, you guys, a couple of things need to happen right now. I need to remember to check roll, okay? And when I finish checking roll and I start teaching, I need to remember to do what? That I forgot last period. Start the video. Right now, I need you to see if you can, I've asked you to think about 2 quantities, things you can put numbers on. We talked about money and time and all sorts of things that number, things that you're going to put numbers, and try to come up with, I'd love if you could come up with 2 that you think do correlate and 2 that you think do not correlate. But give me something, because every one of y'all was about to give me one of your ideas. So come up with at least one, because you're about to share that with me. I am going to check roll, and then I am going to start the video. I'm also going to fix the typo in the notes that we found last period. And what the heck is this? Huh?
Is it the A,
What is the what?
the typo?
Oh, no, it's not in that. Is there a typo in this? Do you see one while I'm there?
Think of A2 variables.
Okay, new typo. Hang on. Now I've got 2 of them I can fix. All right. Yeah, nobody noticed that one. That's not the typo I was looking for, but I would like to fix that one too. Hold on. Scrolling down on my page 24 now, but it's on 23. Wait. What does that page look like at the top? Past the empirical rule. Something happened. What? Oh my stars. Oh no. Hold on. I can save this. I changed something for next year and ended up dropping a picture right in the middle of this page and everything went insane. That's okay. I got rid of the extra picture. Think of, oh yeah, it's got a little squiggy underline. It doesn't like think of A2 variables. Think of 2 variables that are not likely to have any correlation. Good job. And then the other one was, hang on. I think I fixed it last period. Maybe I can see it. View graph to compare this line. Oh my stars, I forgot what it was again. Dang it. And I didn't highlight it because I just opened it up and then we were talking about something else. Wait, hold on. I think it's at the top of this page. Can help determine the relationship between the variables. Jeez Louise. Hang on. Y'all keep thinking about your thing. Yeah, maybe y'all will find my mistake. Okay, can't find it. All right. I did check. I don't even think I checked wrong. So much for multitasking. Y'all still thinking of a couple of variables and whether you think they would correlate or not, positively or negatively? All right. And we have been recording for, oh, I did start the video last period. It's been recording for 47 minutes. I will stop this video.